Hi all, it's Mr. Yeager for AP Physics 1. I'm going to try to go over the difference between gravitational mass and inertial mass. It's a small topic that's included in AP Physics, and there's two things we basically are interested in trying to make sure we understand with these two properties. They usually ask a few questions on multiple choice. I've never seen it in free response yet, but I wouldn't be surprised if they ever did throw it at you. So there's two main things that we need to understand about gravitational versus this inertial mass. The two things we're going to look at are, first off, obviously, what are they? All right, what distinguishes gravitational mass versus inertial? So what are the definitions, basically, of each one? How do we define them? And then the second thing is, how do we find them experimentally? Okay? And that's basically it. It turns out we're only going to go over a little bit of how to find them experimentally. We'll keep on introducing later on, especially when we get into springs, where you can actually use springs to help you find inertial mass as well. We'll talk about that as we get to it. So what are the differences between these two? We've opened up the formulas to find these now through the dynamic force unit. And so now, how can we get them? All right, so I'm going to start off with gravitational mass. Gravitational mass is really what we've been calculating all of the time. I should say that. Technically, we haven't calculated inertial too. But this would be the one that we primarily think about when I say what's the mass of the object, okay? Gravitational mass is going to be based on the object's weight. All right? It's basically saying what is the mass that's being pulled, all right, by the gravitational field, aka gravity, G. Okay? And so there's really only one way to figure this out. If we're saying gravitational mass is based on an object's weight, what do we have to calculate? Okay? We need to calculate weight. Okay? We can find the gravitational mass, that would be this right here that I'm underlining. Okay? That M would stand for gravitational mass, and it would be found by finding the weight of the object. Okay? Find weight. Okay? And how can we find weight? Well, we can use a spring balance. If I said, please figure out the gravitational mass of an object, you would say, hey, I'm going to use a spring balance and basically hold it straight up and down. Okay? Basically, hang the weight. All right? Let it stay perfectly still, measure the force, divide out G. And then we'd have what would be called our gravitational mass, the M. So weight's not the gravitational mass, it's M. All right? So that's it. That's how we gravitational mass measured on weight, basically use a spring balance to find. Okay? Inertial mass is the one that's a little bit more tricky, but probably more difficult to actually measure in the lab, but we have a formula for it. Inertial mass, the definition would be basically the mass that gets accelerated. Okay? It's, as I usually say to everybody, it's the mass that is in motion. Now, technically, it doesn't have to be, but that's usually the way we're going to use to figure out how much it is. Okay? And so the formula for inertial mass is our net force formula. When we find the mass using F net equals m times a, the m that we find with this formula would be considered or called the inertial mass, because it's the mass that is being put into motion. It's the mass that's trying to resist motion, which is what inertia basically is, to resist a change in motion. All right? So when we find that mass, that is the inertial mass. So this one's going to be a little bit more difficult to try to do. For an experiment, what you're basically looking for is we have to use this formula to figure out the mass of the object. So when we do an experiment, we basically need to put an object into motion. And somehow find the acceleration and the net force on the object. Okay? And so that's important because if we do that, this is actually another big part of this unit, we can actually make a particular graph. If we graph net force versus acceleration, we should actually see just a straight line going up. If I'm pulling in one direction and say I'm accelerating and creating that force in a positive direction, it should be a perfectly sloped straight line. And then the slope means something. Well, what does that mean? What would the slope mean if I have net force versus acceleration? Well, line it up. Line it up with the line equation. Net force equals m times a. Y equals mx. Look at that. If net force is on the y-axis, if acceleration is on the x-axis, the slope, this is the slope, the slope would equal the mass. So if you find the slope of this line, you can find the mass. Okay? And that's it. And this would be considered the inertial mass. All right? Now, be careful because it's possible, I have seen in the past, where they'll give you a graph like this, where it's A versus F net. Okay, A versus F net. All right, it actually will still be a sloped line, actually a perfectly sloped line still. Okay, the issue is people usually mess this one up. The slope will not equal mass. Okay, that's not right. We have to look at my equation. F net equals m times A. This time I put F net on the x-axis. I put A on the y. So what do I need to do with m? I need to move it to the other side because it's y equals m times x. Well, in order to move it to the other side, what do I have to do? I have to divide it. I have to divide both sides by m. All right? And so that leaves me, I'm going to rewrite this as 1 over m times f net equals a. Y equals m times x. So the slope of this line actually equals 1 over m, so then you'd have to make sure to take the inverse to figure out the m, the mass. Okay? Now, last quick point I want to make, and this is why I find this whole topic a little bit silly, is every experiment that has ever been done, every experiment trying to test how gravitational mass and inertial mass are different, all right? Every experiment has actually shown that the gravitational mass equals the inertial mass. And that's kind of like a, well, duh, because these are the same object. It's the same mass, so why would they be any different? All right? And again, it just goes back to how are they found? And that's, again, what's the definition of both of them? How are they found? Gravitational mass depends on weight, equals mg, while inertial mass would be the net force Newton's second law equation, equals m times a. But the mass is the same, it's the same object. The only place where it might be different, where you wouldn't be able to calculate it, would be like in the middle of outer space. If you have no gravitational field acting on the mass, you can't necessarily calculate it. Now, it doesn't mean that the object disappears. It still has inertial mass in outer space. All right, it's just there's no way to calculate the gravitational mass. It's still there. It's just no way to calculate it. All right, so that's the main idea. Gravitational mass will equal inertial mass, essentially in all problems. We're going to look at an experiment with this a little bit later, and we'll go from there. Thank you.